Hi everyone, this is Mr. Malas here from my home in West Roxbury, Massachusetts, just down the road. I'm here today to talk to you guys about evaporation. We've been talking a lot in class about water and its most microscopic forms in terms of gas, liquid, and solid. We've looked at how molecules move around in all of those different states. But one of the most important and interesting things about water is its ability to change states, and our ability to change water between its states. And today we'll be talking about evaporation, which many of you know very much about from the carrot observations we've been taking over the last 2 weeks. So let's get started. Okay, so typically when we think about evaporation, the first thing that usually comes to mind is boiling. So if, for instance, here on our stovetop we have this nice pan here filled with water. The temperature, we've turned up the heat to almost high. We're beginning to boil the water. We're increasing the temperature of the water so that the water changes from its original liquid form into this rising gaseous steam form or water vapor. However, it's important to realize that evaporation can take place at any temperature, and as long as there is enough energy that will enable the water to turn into a gas form. As an example of this, I've put out 2 glasses of water on this table. The first glass of water was on the right here was put out about 3 hours before the glass on the left. And you'll notice a significant difference around the rim of the glass on the right, which has been out longer than the rim on the glass on the left. The water bubbles that you see near the surface on the right glass is due to evaporation. So all types of water actually have pockets of air within all the water molecules in the glass or in any type of container. So over time, due to the fact that gas is less dense than water, because it's less dense, it will rise to the top of the glass just like ice cubes rise to the top of glass because ice is less dense than water. So over time, because the temperature is high enough in the surrounding environment, the water bubbles containing the gas will float to the top until the bubble pops and the gas takes off into the atmosphere. So hopefully that gives you a nice introduction to evaporation. So now the point of today's activity, and what we'll also be doing when we get back to school on Monday from break, is really emphasizing what type of environmental variables control the rate of evaporation of water, changing from of water into gas. So there are 4 main types of environmental variables that control rates of evaporation. The first of those rates is temperature, so air temperature. The second of those variables is light, not light like coming from the ceiling, which actually is a measure of heat. So these lights here give off energy, and then that energy changes temperature. What I'm talking about is light coming from the sun. So it's actually dark out right now as we're making this video, but think of light as solar radiation. So the amount of radiation coming from the sun. The third environmental variable that affects evaporation is wind. And the fourth environmental variable that affects the rate of evaporation is humidity. So humidity is a measure of the amount of water vapor that's in the air surrounding the liquid. Okay, so now I'd like to describe to you what I'd like you to do for an at-home assignment over break, which you'll be collecting observations in your own homes and then bringing the results back to class on Monday when we get back from break, or Tuesday if you don't have science on Mondays. So the point, again, of this experiment and of this lesson is what environmental variables control the rate of evaporation. So in order to investigate this, what I'd like you to do is first find 4 brown napkins or dark colored napkins around your house. And put the napkins out side by side on a table. Then you'll find a teaspoon from your kitchen. You'll fill the teaspoon of water, and then you'll dump the teaspoon of water on the napkin, as so. Then you will go around to 3 different rooms in your house with varying environmental conditions, so that the environmental conditions follow the 4 that we discussed earlier. So air temperature, solar radiation, wind, and humidity. So you'll go around to each of the 3 different rooms in your house, and you'll take notes. So on a rough scale of 1 to 10, 10 being the warmest, 10 being the most light, 10 being the windiest, and 10 being the most humid, what those conditions are like. And I'll provide further instructions online. And you'll be writing those down for each of the 3 locations in your house. So I'll show you an example. So I'll go to the bathroom in our condo. So here we're in the bathroom, and we'll place the napkin out, and what we'll be doing is we'll be going back every 10 to 15 minutes, so you get a stopwatch if you have one, or you can just look at the clock, and you'll be checking every 10 to 15 minutes to see whether or not the napkin has dried back to its original form. And so just you can feel it and just compare it with the napkin as it originally was. And so in this bathroom, the temperature is about room temperature. So I would say it's about a 5 in terms of temperature. If you have a digital thermometer, like a meat thermometer, that would be helpful. So compared to room temperature, there's no solar radiation in here, so that would be 0. There's no wind, so that would be 0. And the humidity is probably average, so I would say that's about a 5. So I would write those 4 variables down. I would check every 10 to 15 minutes to see how dry my napkin is. And then I would write down, once it is completely dried, how long it took. Okay, so I hope you find this investigation worthwhile. I'm hopeful that you come to class on Monday with lots of questions, an inquiry about what's really controlling evaporation. And we'll be doing some fun activities in class to go along with that. But just a couple final notes. So when you put out your napkins, make sure you tell your parents if they're around so they don't pick them up and ruin your experiment, because you wouldn't want to have to start over or to do the experiment over. It might take an hour or so, depending on the type of conditions that the napkins are in. And last but not least, it's really important that before you start the experiment, before you put out the napkins, that you know where you're going to put the napkins, that you make hypotheses based on your previous knowledge, which napkins you think are going to dry the fastest or dry the slowest, and see if your hypothesis is accepted or rejected after your results come back in. So again, let me know if you have any questions online. I'll be checking periodically over break. And again, I hope you have fun. I hope you have a relaxing break, and I'll see you on Monday.
Will you hold up the paper for a sec?
Hi, Mr. Malas here. From my... Oh, God. Hey, guys!